We're about to tackle some challenging Year 9 Paper 2 exam questions, so rid yourself of all distractions so you can focus. Let's go! Maybe by now some of you have sat your first paper and you may be feeling confident with the scores that you have gotten, while others of you may feel like you didn't do as well as you hoped to. But be encouraged. Remember that your final grade is an average of both papers. This means that we will need to extensively revise for paper 2. A comprehensive understanding of all the objectives covered in both videos will help to change your final score. So, let's get started. Before we begin, I just want to talk you through a few essential examination tips. So, let's begin. First tip is about reading the questions. So, tip number 1. Read the question twice or even 3 times if you've got the time. Next, underline or highlight the important information. And I'm sure once you've been following me, every single lesson I always make sure I underline the key information because I want to give myself a focus on what the question is asking me to do. Next, ask yourself, what is this question asking? What does the answer look like? Next, work through the question. Then ask yourself, have I answered that question the way I was asked? So, have I answered the question that was asked? Because sometimes we do answer question, but not the one that was asked. And for example, if the question says estimate or approximate, you cannot do the actual calculation. You must round all your values in the question to one significant figure. Make sure that you do that. Next, particularly on a calculator paper, we tend to believe that if I put my working in the calculator, then I do not need to ink what I'm thinking. Wrong concept here. So, as it relates to working, you must show your working out on the spaces provided for each question. Very importantly, a wrong answer with no working gains no marks at all. However, if you have a wrong answer with correct working shown, yes, you can score up to 4 out of 5 marks or 3 out of 4. Awesome thing to know right there. So for all those people who always say, I don't need to write the working out, you are going to cheat yourself if you do this. So remember, show all of your steps, even if the answer is wrong, but your methods are correct. You can score up to 4 out of 5 marks. Now, as it relates to diagrams, most of the times the diagrams that you're given will say not drawn accurately or not drawn to scale. That's very important. So almost all diagrams are not drawn to scale, and they will state not drawn accurately. Now, do not measure an angle or a line unless the question specifically asks you to do this. You will use incorrect values if you do so. Now, also a very good practice is to, once you identify, for example, your angles, always write on the diagram to close in your gaps so you can see what other missing elements that's there that you need to find. And final tip, as it relates to equipment, you have to make sure that you are prepared. So what do you need? You need a ruler marked out in centimeters or millimeters. You also need to make sure you have your protractor. You may be asked to measure angles. You also need to have a sharp pencil. Make sure you have a sharp pencil, because when you're measuring your angles, you will only be allowed to be 1 degree off in terms of above or below the actual answer. So let's say, for example, the angle was 25 degrees. If you have 24 or 26, you can score the mark, and a sharp pencil will ensure you to stay within these boundaries. Next, you need to have a compass. Some questions will ask you to construct. If a question asks you to construct, you cannot draw. You must use a compass and a pencil to do so. Also, writing a formal examination, you need to have a black pen. And for your calculator paper, this one, you need to have your calculator. So make sure it's your calculator, and also you know how to operate this particular calculator. As it relates to working out your angles, make sure your calculator is on degrees. You must see that tiny little D at the top of your calculator on the face. If you're not seeing that before you begin, ask your teacher for help to make sure that you've got this. So let's get into our questions. Now, first question here says a piece of wood has a mass of 8 grams and a volume of 10 centimeters cubed. We're asked here to work out the density of the wood. Now I'm going to demonstrate what I've just said to you. I've read through the question once. Now I'm going to read with intention to highlight my key factors here. So a piece of wood, let me just visualize that wood, has a mass, so I'm going to underline that, a mass of 8 grams. So I'm going to take my words now out of the question. So I'm just going to write here mass equals 8 grams and a volume, so underline that, of 10 cubic centimeters. So I'm going to write volume equals 10 cubic centimeters. Now I'm asked to work out, again, what is the question asking me for? The density. So work out the density. So let's write that. Give ourselves that focus. I need to be working out the density. Now I need to ask myself, what then is the formula for density? So I can visualize this with a triangle. So mass at the top of my triangle, density and volume at the bottom. So I'm just going to remove that diagram for clarity there. So therefore, I'm finding the density. So my density is equal to my mass divided by my volume. And also remember, you have learned how to rearrange to make different variables the subject of a formula. So using this triangle, I can see if I multiply density and volume, I will get the mass. However, if I divide mass by density, I get my volume. And if I divide mass by volume, I will get my density. So density is equal to mass divided by the volume. Now, before you start substituting your values, it's very important here to make sure the units you're given are compatible. So grams and centimeters are the two units that are compatible. Kilograms and meters are compatible. So if you haven't been given the compatible units, you would have had to do your conversion first. So these are compatible. We can go straight ahead and substitute. So let's go. So therefore, the mass I wrote down was 8 and the volume was 10, a very nice one, even though it's a calculator. I'm just dividing 8 by 10, so the answer is 0.8 and the unit is grams per centimeters cubed. You make sure you end most questions sometimes on the answer line. They'll give you the unit unless they are testing to see if you know the unit. So we've completed that beautiful question on compound measures. So let's go to our next question. So Isabella is loading granite tiles into her trailer. they can carry up to 600 kilograms. So I'm just going to go ahead and underline that. That's a capacity of the truck. Each tile, so each single one tile, measures 30 centimeters by 30 centimeters by 2.5 centimeters. So I underline that. Now the density, so I'm underlining the word density here, of the granite is 2.7 grams per centimeters cube. Again, checking compatibility. Yes, they are compatible. Isabella says she can place 100 tiles in the trailer. Is she correct? And you're asked here to explain your answer. So here is a visual of a beautiful tile. So how do we approach this question? Now, once we have read the question, you should have noticed also this is another question where we are doing compound measures. So then I want to find out if Isabel 100 tiles can fit into her trailer. So the first thing I'm going to need to do is to find the volume of the tile, and then I need to find out the mass of all of the tiles and see if they'll be able to fit in the truck. So let's go. So I'm going to work out the volume first of all. So the volume, we know we just need to multiply 30 centimeters by 30 centimeters by 2.5. And again, remember, it's a calculator paper, so I would advise that you use your calculator even when things seem very simple. So I'm just going to go ahead and put that in my calculator. 30 times by 30 times by 2.5. So the volume then is 2,250 centimeters cube. Okay, now I have been given the density in the question, so I'm just going to go ahead and write the density down. And remember, we are after the mass. So density here is 2.7 grams per cubic centimeters. So I'm going to go ahead and I'm going to calculate the mass. So remember, mass is at the top of my triangle. So mass at the top of my triangle, and I've got density and volume at the bottom. So I want the mass, so I have to multiply. So I'm going to multiply the volume, which is 2250, and I'm multiplying that by 2.7. I go ahead and I put that in my calculator. So I've got 2,250, and I'm multiplying that by 2.7. And that gets me 6075. Okay, now I notice that this is in grams. Now, if I'm going to see if all of the tiles can fit in the truck, I've got to make the units compatible. So what I'm going to do is to convert the grams to kilograms and see what is the mass of one tile. After we found the mass of one tile, we now need to work out the mass of all 100 tiles. So let's go. So I need to know my conversion. 1,000 grams is equal to 1 kilogram. So to convert from grams to kilograms, I'm going from a small unit to a large unit. So small to large, I divide. So I'm going to do 6,075 divided by 1,000. So I go 1, 2, 3 spaces here. So it's 6.075 for one tile. And this is now in kilograms for one tile. Just write that down. So now all I need to do is to multiply this by 100 to find out the mass of all 100 tiles. So I do 100 multiplied by 6.075, and I go 2 spaces to the right. So my answer is 607.5, and this is now in kilograms. So all I need to do now is to check is this smaller than the capacity of the truck, or is it larger? So I am comparing 600 kilograms with 607.5 kilograms, and I can see that the mass of the tiles are more than the capacity of the truck. So I must conclude intelligently. I now need to say, to answer the question, is she correct? Explain your answer. I now will say no, because the tiles are more, and you can also go ahead to say 7.5 kilograms more than the capacity of the truck. Okay, so that's how we make sure that we answer intelligently. So the tiles are more, 7.5 more than what the truck holds. Okay, it's very, very important to make that conclusion. Now, if you have gotten all of that steps down and you didn't make a conclusion, you would have lost 1 mark. And remember, 1 mark is the difference between 2 grade boundaries. Absolutely fantastic. So let's go to our next question. So for the next question here, we're told that the diagram shows a solid triangular prism. Underline, triangular prism. We observe our diagram, we see the measurements we have, and also what we do not have. So the prism is made, very important word, prism is made from wood and has a mass, so underlining mass, of 643.8 grams. The density, underline, of the wood is 1.85 grams per centimeters cube. Check for compatibility. Yes, they are compatible. Calculate the length of the prism, which is given on the diagram to be x. So how do I approach this question? Now, I know that the volume of a prism is equal to the area of the cross section, which is the face of the triangle on this diagram, multiplied by the length. So let's write that down first of all. So the volume would be equal to the area of the triangle. I'm just going to write area of triangle multiplied by the length. So let's go ahead first of all and find the volume of this prism, but we've got to do it in terms of x because I do not know the length as yet. That's what the question has asked me to find. So I know the formula for the area of a triangle is the base multiplied by the height divided by 2. And then when I find that answer, I will multiply that by my length. So let's now substitute. The base is 6 and the height of the triangle is 8. Then I need to divide that by 2, and then the length given is x. So let's just simplify. We put that in our calculator. Very simple calculation, but use your calculator to your advantage. So I need to do 8 times by 6 and then divide that by 2, which gives me 24, and then 24 times x gives me 24x. So now I know the volume of that triangular prism. So I'm given my mass and I'm given my density. So I know that volume is equal to my mass divided by my density. So what I'm going to do is to write my volume in terms of what I just found, which is 24x. So let's go. 24x is equal to, I go back to my data, the mass is 643.8. I need to divide that by the density, which is 1.85. And then I'm going to solve this equation. So I'm going to put that in my calculator, 643.8, and I'm dividing that by 1.85, and that gets me 348. So 24x is equal to 348. Now I need to make x the subject, so all I need to do is to divide by the coefficient of x, which is 24 on both sides. So put that back in my calculator. So 348 divided by 24 is equal to 14.5, and the unit is centimeters. And there we go. Notice clear logical steps. It's integrating all of the formula that you know. So we know how to find the area of a triangle. We know how to find the volume of a triangular prism, or any prism, of a matter of fact, and also how to find the volume. We execute the operation, we talk to ourselves, we ask ourselves questions, and of course we can also prove our answer at the end. Beautiful. So now we are going to do a little bit of construction. So the first question on construction says, using, very clear here, using a ruler and compass only, construct the following SSS triangle accurately. And SSS we know means side, side, side. Awesome. We are given the triangle and we're given the dimensions: 4 centimeters, 5 centimeters, 6 centimeters. Now, this is not drawn to scale on the question. You are asked to produce the accurate drawing. Hence, your equipment comes into focus. So the first step we need to take here, step 1. We always draw the base of the triangle first of all. So you need to get your ruler and you're going to mark off in centimeters exactly 6 centimeters. Remember, starting from 0. So we mark off and this must be done in a pencil so you can erase. You will not be given another exam paper, so you've got to use a pencil. So you label as you go along. Step 2, we are now going to draw 2 arcs from either side of the line that we have drawn. We look on our diagram. One of them has to be exactly 4 centimeters and the other has to be 5. So now we need our compass. So we're going to put our compass at the very end of the line. So I want my 4 to be projected from the left. So I put my compass point on the left hand end of that line. I open my compass with a radius of 4 centimeters, dead on 4. I then swing an arc all the way around. So I need to do that on the other side. But now the measurement has to be 5 centimeters. So I put my compass on the other side of the line. I open to exactly 5 centimeters. Now I swing an arc to intersect the one I did before. Once I've done that, all my construction lines are in place. I now take my ruler and I'm going to connect the end of both lines to the intersection that I had on my diagram. I now put my labels in, so 4 and 5. Very important note here, do not erase your construction lines. This is what your examiner uses to know that this triangle was not drawn but rather was constructed. Amazing. So that's our side, side, side. Let's explore another triangle. So using a ruler, compass and protractor, construct the following side angle side triangle accurately. So clear instructions, clear equipment given here. So again, I know you've got it that we are going to draw the base one first. So we go ahead and we use our ruler to draw 7 centimeters. So I mark that off and then I put that label in. Amazing. Our next step, we are going to now draw an arc with a length of 8 centimeters. just like we did before. So now I'm going to take my protractor. Now I'm going to open a radius of 8. And once I've done that, I'm going to now swing an arc above. Beautiful. But this time my protractor comes into place because now I have an angle to draw as well. So I'm going to take my protractor. Remember, the center of your protractor must be at the end of the line, and the baseline, which is on 0, has to be on the line that you drew for 7 centimeters. Now, it's very important here to pay attention to your scale. Remember, your protractor has an inner scale and also an outer scale. So I need to use the scale that's on 0 on the line that I drew. Okay, so I can see it's the blue scale that we're using, and we need it to be exactly 40 degrees. So I find 40 and I put a mark with my pencil, sharp line going there. And then all I now need to do is to use my ruler, and I'm going to, from the end of the line, make a connection to touch the arc that I drew. And the other side will just be simply you using your ruler to complete your triangle. Now, as many times as you need to rewind and watch this, please ensure that you do that. You do not know if you're going to get one of these, and also which one they will ask you to construct. But with anyone presented to you, I know you're going to be ready. So that's what we need to do here. And re-emphasis, do not erase your construction lines. Beautiful. So now we're going to do the last construction before moving on. So this time we're asked here, so using a ruler, compass and a protractor, construct the following angle, side, angle, triangle accurately. So now we've got 2 angles to draw. So again, step 1, we are drawing our base first, which is 7.3. Now we have to pay attention to our millimeters, those tiny lines. Every single tiny line represents 1 millimeter. So let's get our ruler. So I need to count. I can see that halfway between 7 and 8 would be 7.5. So that means if I count from 7, 3 tiny lines, that would be 7.3. So let's go. I now need to make that line. Then I'm going to now take my protractor to measure both angles. So first angle has to be 35 dead on. So I'm going to mark off my 35, observing the correct scale, the inner scale. So put a line there. Then I put my protractor on the other end of the line. Now I want to mark off 52, but now I'm using the outer scale because it's the outer scale that's on 0 on the line. Very, very important. So I mark that off, and then what I now need to do is to simply use my ruler, line up properly, extend my lines, extend the other line, put my angles in. Please do not forget to put your measurements in. So 52, 35, and then you can simply take your pencil and your ruler and just brighten the triangle in focus, and remembering, do not erase your construction line. I am so proud of you for investing in yourself. Simply coming to do some independent studies. Absolutely fantastic. Now, before we get into the next question, I just want to pause to tell you thank you so much for being a part of the Upgrade family. Thank you so much to all those who have subscribed, shared, liked the video. I truly appreciate you. It tells me that you are interested to upgrade your grades, which is absolutely brilliant. And you know what I'm going to say now, you are becoming brilliant by numbers. Thumbs up. So with that being said, let's go into our other question. Now, this time we're going to look at different types of graphs. Now, before I start, you could just pause the video and make a note and say, do I know the different types of graphs? Write them down and see if I've covered all the ones you know. So let's go. So the first type of graph that we're going to look at is the linear graph. So of course, once we hear the word linear, the first thought that should come to our mind is a line. The word linear comes from the word line. Amazing. So what we're going to do now is to just remind ourselves of what this looks like graphically. So first, remember, a linear graph is always in the form y equal mx plus c, where m is our gradient and c is our y-intercept, which tells us where our straight line crosses the y-axis, and our gradient tells us the steepness of the line. So I've just pre-drawn this because it's very difficult to draw a straight line here. So this line is an example of a linear graph. However, we've got to make sure we can distinguish between our linear graph that has a positive gradient and our linear graph that has a negative gradient. So for this one in question that we're looking at, we can see that the line slopes from the right to the left. This means that it will have a positive gradient. So an example of that could be y equal 2x, let's say plus 5. So this is not the graph I'm describing, just an example of what the positive gradient looks like. Then I look at another orientation. Now, when my graph slopes from the left to the right, it will have a negative gradient. So the gradient will be negative. For example, y equal minus 5x plus 3. The gradient is negative because the graph slopes from left to right. So that's our first type of graph we need to know, and also to be able to identify gradient and y-intercept. Then we look at our quadratic graph. So this one I'm going to draw in. So the quadratic graph is always represented in the form of a parabola. So I can have a parabola that has a maximum value. Now, for the quadratic graph, it is not what it looks like. It is when we have a maximum value, the coefficient of x is negative. So for example of this one, we could have y equal, let's say, 2x squared. So the quadratic graph always have a square. So it could be y equal 2x squared plus 3x add 5. Key point here, the coefficient of x squared will be positive whenever, it will be negative whenever the graph has a maximum value. On the other hand, if I draw my parabola this way, my graph will have a minimum value, but the coefficient of x squared will be positive. So for example, y equal positive 3x squared plus 4x, for example, plus 5. I'm just putting random numbers there, but the key point here, if it slopes low parabola, then it's positive. It's really tricky because you would have think that because it sloped to the positive direction, the coefficient of x squared would be positive, but that's not true. Negative coefficient will have a maximum value and a positive coefficient will have a minimum value. Can be very tricky for that one, so make sure that you focus on your gradient. Okay, so now we're going to move on to look at some other graphs. So we have the exponential graph. So with an exponential graph, lots of businesses will use this just to look at the rise, for example, in their business to see, you know, am I making money or am I losing? So my exponential graph always comes very close to the x-axis and then it will go up by a curve showing you progression. Okay, it could also be a negative one, but for key stage 3, we focus on the positive one. Now, we also have our cubic graph. So our cubic graph sort of looks like a wave. So if I try to sketch one here, so could pass through there, have a slope. Now also, just like the linear graph, I could also have a negative and a positive cubic graph as well, and the orientation is the same. So therefore, if I slope from the right to the left, then that would mean that this is positive. I could also have done it the other way around, where I'm coming this way. So I'm just going to try to do it there, a wave, but it's from the other side. So that one would be a negative cubic graph. So it's pretty much like a part of the quadratic, but then we've got waves, and then we look at our orientation. Okay, then we look at last one, which is our reciprocal graph. And the reciprocal graph here usually more looks like it has a reflection. So if I should try to sketch one here, then the other side will look this way. And it could also have been from this side as well, and then the reflection of it would be on the other side. Okay, so that is my reciprocal graph. So there we have it. You can rewind and look back at the different types we have, but key point here is to be able to identify them when we're asked, and also to say them by their names. We look at gradients and also we look at gradients to determine, is this positive, is this negative? Do not just go ahead and just match because it's a straight line. Look, is it a positive gradient, is it a negative gradient, and so on. Okay, now we go to our distant time graph. So shown below are 6 distance time graphs. Each sentence in the table describe one of the graphs. Write the letter of the correct graph next to each sentence. So we observe our graph, we look at what's going on, and then we look, the first one was done for us. So here we're told that Mr. Jones traveled to work and immediately returns. So therefore, the first one, F, we can see from starting point, he has not stopped at all. There is no straight line across. Horizontal line usually indicates when someone is at rest. But we can see here in graph F, he just went to work, he just turned around and left at the same time. So that's F. The second statement says, Mr. Jones leaves work and travels home at a steady speed. So therefore, not rushing, nice and smooth. So if we observe all the graphs here, we can see for the graph D, he leaves work, so he was at work, so which is right here on the y-axis, and a nice straight line back to the origin where he started. So the first one is graph D. You could pause as well at this point and see, could you identify what they are? So the next one says, Mr. Jones leaves home and travels to work at a steady speed. So we're looking for him at the origin. So here, steady speed again. So it is graph A because we are at the origin, very straight line until he gets to his destination. So that one is graph A. Next statement, Mr. Jones stays at work. So we're looking for a long rest period, a horizontal line to depict his stay at work. This is where he is stationary. We can see that the only graph that shows a stationary period is graph C. So therefore, we have 2 other options left. So Mr. Jones travels to work, stay there for some time, and then returns home. So there is some form of rest period. So if we look here at graph B, we can see from the origin, he travels up, has a little short stay and then returns home. So that one is graph B. Now a good idea would be to read through all the sentences first and then go back to do it, but in the interest of time, I just want to show you how to answer the questions. So Mr. Jones leave home, even though it's the last option, still read it, just in case you've messed up somewhere on the top bit. So Mr. Jones leaves home and travels to work, stopping at a shop on the way. So that means this rest will happen, and after that rest there also has to be a continuation towards his destination. So we can see that is for graph E. We can see from origin, travels, here's the shop, stop for a while, but then continues to work. Distance time graphs are very popular on exams as well, so it's very important that we know not only to identify what they're saying in terms of matching sentences to graphs, but also to answer questions from the graphs as well. Okay, so let's move on to our next question. That is actually asking us to answer questions from the graph. So here we're told Edward drove 80 miles from home to London. So let's underline the distance traveled. He stopped and visited his friend Nicola on his way. Here is a distance time graph for the journey. So we observe the graph, we look at the scale, we can see on the x-axis here is the time of day of which he's traveling, and also on the y-axis the distance from home. So that's the y-axis. Now our first question say, very simple question, how far was Edward from home when he visited Nicola? So we look on the graph, we can see here at 9 o'clock he's at home. We can see that where he stopped here at 10 o'clock, we look on the y-axis to write off the distance, and that is 40 miles. So I'm just going to draw a line across here. So he was 40 miles away from home when he stopped to visit her. Next question say, how long did Edward stop for? So that would mean it's from the beginning of that horizontal line to the end of the horizontal line. All we have to do is to look at what time he stopped. So we can see here he first stopped at 10 o'clock, and then all the way to the end of the line is 11:30, because we can see the graph is going up in increments of 1 hour. So halfway between 11 and 12 will be half an hour. So that's 11:30. So therefore, from 10 o'clock to 11, that's 1 hour, and then half an hour. So it's 1 hour and 30 minutes. So that's how we answer a question. That was a nice and calm question there. Always just show your examiner that you've interacted with your graph. Notice I've drawn lines to show what I'm reading off, and also put an asterisk between my start and my end points for the time. Awesome. So now we do another one where we are asked to draw something on the graph. So Henry takes place in a 100-meter race. I can see that there's a little fault with this question. So this should say Henry takes part. So let me just cross that out. So Henry takes part in a 100-meter race. The diagram shows the distance time graph of his race. So we observe first of all the graph before we start answering any question. So I can see on my x-axis, my time is given in seconds. I'm just going to label this X, get in the habit of doing that. And on my y-axis is the distance from start in meters. Part A. How long did it take Henry to run 100 meters? So I need to go to 100 meters on my graph. I go across until I touch my line that has been drawn to represent the race. And once I touch that, I come down along and I read off the value on the x-axis. So the answer for part A is 20 seconds. Take that off and now focus on part B. So the question says, what was Henry's average speed over the race? So this is where I write my formula for speed. So I know for my triangle, distance is always at the top and speed and time at the bottom. So I want to find out the average speed. So therefore, speed is equal to distance divided by time. So I go back and it says, what is his average speed over the race? So his distance traveled was 100 meters. So I'm just going to substitute that in for distance. And the time taken we found in part A was 20 seconds. So therefore, I need to just divide 100 by 20, and that gives me 5. So therefore, he has traveled average speed 5 seconds per meters, or 5 meters per second, all the way around. So 5 meters per second. We can just write 5m/s. Awesome stuff there. So the final question is, Helen completes the race in 16 seconds. So another participant here. We are asked here to show this on the graph. So we know it's the same 100 meters. However, this time it is done in 16 seconds. So what I need to do is to identify on my graph where is 16 seconds, and I need to go all the way up to 100 meters. So this is where my 16 is. I'm just going to put a star there. So what I need to do now is to take my ruler and connect that mark with the origin. So I've pre-drawn that in because lines are very difficult to draw. So it should be from here, a little bit off sync, but from the origin all the way to the top. That would be the exact marking of that race, and that is Helen's. I've put that in a different color, but you could also have just written the name here. So Helen would have taken from the origin, straight line there, all the way up to 100, and on the x-axis 16. Very good. So we go now to look at surface area, and we're almost there. Great. So this question asks us to calculate the surface area of this triangular prism. So to do that, we focus first of all on what is meant by surface area. So surface area simply means the area of all the faces of this prism added together. So we're going to take it one part at a time. So first of all, I recognize that I've got two triangles here, one at the front and one at the back, and they are identical. So I can either find the area of one triangle and double it, or if I multiply my base and my height, I do not need to divide it because it will be for both triangles together. Well, I'm going to take the part of finding one triangle and then doubling it. So let's call this one shape 1 and the other triangle shape 2. And then we'll come back for the other faces. So the area of triangle is equal to base times by height divided by 2. So I identify my base. Remember, my base and my height has to be perpendicular, which indicates that they must form a right angle. So I can see here my base is 6 and my height is 3. So I'm going to do 6 centimeters times 3 centimeters, and then I need to divide that by 2. You will see that we didn't need to do that. However, I'm just going to talk you through it nonetheless. So 6 times by 3, put that in your calculator. It's 18 divided by 2, which is 9. So you can see, if I know the area is 9 centimeters square for one triangle, I just simply need to multiply that by 2 for both of them. So that will take care of area 1 and area 2. So 18. So therefore, that's what I meant when I said we could have just done 6 times 3, and that would be the area for both of the triangles. Awesome. So now we need to find the area. I'm going to find the area of the top. So the top of the shape consists of a rectangle, 7, I like that for you, and also along here is 10. So let's call the top of it face 3. So area 3 is a rectangle, so that will be equal to the length, which is 7, times the width, which is 10. 7 times 10 is 70. Again, put it in your calculator. Use your calculator to your advantage. So we have found 2 faces here, 3 so far. We've got 2 more to find, and then we add them together. So I'm going to find the area of the face that's at the back, which is also a rectangle. Important, make sure you do not mix up your units. So I can see here, this bit along is also 10, because the front is 10, and also the length here is 3. So for area 4, I'm doing 10 centimeters multiplied by 3 centimeters, which gives me 30 centimeters squared. So I have my final face to find, and that's the face that's on the floor, the side on which the prism sits. So I've got 10 along for the floor. I'm just going to label that 5, and I've got this side across, which is 6. So area 5 is equal to 10 centimeters multiplied by 6 centimeters. 6 times 10 gives me 60 centimeters squared. Final step is to add them all together. Not as difficult as you thought. Okay, so let's highlight. We've got for the first 2, 18 centimeters squared. The second one, I've got 70 centimeters squared. Then I've got 30 centimeters squared and 60 centimeters squared. I just simply need to put them all in my calculator. So I've got 18 plus 70 plus 30 plus 60, and add it all together. That gets me 170. Sorry, my computer screen just went ahead there. So 178 centimeters squared. So checking that I added all the things I need to add. So remember, I should have 5 pieces of information. So for the first one, I've got 2 in 1, so that's 18. Just check that off. Then I've got 70, check that off. Then I've got 30, check that off, and then I've got 60. So altogether 178, and our unit is centimeters squared. Amazing. So we go to our final question on standard form. So we're told in this question, the distance of the moon to the earth is 384,400 kilometers. So distance, I'm underlining that, I'm just going to write it out. D is equal to 384,400 kilometers. The speed of light, so speed, write that down, of light is 2.998 times 10 to the power of 8 meters per second. So I write that down, 2.998 times by 10 to the power of 8, and that's meters per second. Question: work out how long it will take light to travel from the moon to the earth. Include suitable units. So here, how long indicates my time. So remember, distance is always at the top of my triangle, and then I've got speed and time at the bottom. So I'm finding time. So time is equal to distance divided by the speed. So I'm just going to put that in my calculator. So it is 38400, and I need to divide that by 2.998 times 10 to the power of 8. Again, check for compatibility of units. I've got kilometers and I've got meters per second, so green light, they are compatible. So let's just put that in. 384,400 divided by 2.998 times 10. I hope you know how to put powers in your calculator. So times 10 to the power of 8. And I'm going to give my answer suitable, as they've said, units. So I'm going to round to 3 decimal places. So it's 1.282, and that is meters per second. Seconds. So let's write that clear. So it is 1.282 seconds that light will take to travel to the Earth. Now, we've come to the end of this revision session, and I just want to take the time to remind you that you need to go and re-watch the other video as well, the first revision, because remember, exams are just predictions. So therefore, if some of the skills you have practiced in the first video did not come on your paper, it could be that they are going to now be in the second paper. Remember, it is the average that's going to count. So also, if you have a friend in year 8, please share the channel with them, because their revision walkthrough will be coming soon. Advise them to hit the notification bell so when their revision is uploaded, they will be notified. Thank you so much for watching, and all the very best in your exam. Remember, you are amazing.